Today I've got 3 of these little amplifier kits to put together, and okay, that would normally be a boring video, but tell you what, let's do a world-class job and I'll show you some tips and tricks on how to do a really beautiful job. Standard disclaimer, soldering can be dangerous. Wear proper protection. Lead is toxic. Use proper precautions. Solder is hot. Soldering irons are hot. There's dangers of burn, fire, etc., etc. So if you don't know, learn first or don't do it. 30 some years ago, I put together one of the most complex Heath kits that they offered. It was a frequency counter, and when you were done, you took it in, you gave it to Heath Kit, and for 20 bucks they would calibrate it for you and give it back. So I went in to pick it up, and the guy said, it's free. And I said, what do you mean free? And I said, is it not working? He said, no. He said, it's the most beautiful job I've ever seen. I don't want to charge you for it. So that's a world-class job. That's the kind of thing where soldering is an art form, where you're really going for something that's more than just finishing it out and getting it done. You're doing something that really looks beautiful. What's the benefit of that? Well, first of all, there's pride. Second of all, there's the fact that when you're really doing a quality job like that, when you're paying attention to every little detail, you don't make mistakes. You can put together ultra complex kits and not worry about them working or not. Okay, well, this is not an ultra complex kit, but it's going to allow us to look at all the different techniques that one would use across the board. Okay, that's it. Let's get started. One challenge today is this kit came with no instructions. The first step is to clean off everything, and we'll start with the board. My favorite way to clean the board is a little bit of scouring powder mixed with dish detergent and an old toothbrush. Clean it off, make sure you don't do it too much, and remove the markings here on this side. You want to get the oxide off of there. Yes, the flux and the solder will remove some of the oxide, but again, if you want to do a really first-class job, you don't want a lot of flux and garbage. Flux will lift off this oxide and leave it as a little black spot. You don't really want any more of that than necessary. So I'm going to go do that, and I'll be back. And then we'll move on to the second step of cleaning the components. I've cleaned my board. You want to make sure it's dry. I'll set it off to the side while I do the rest. Next step is to clean all of the solder leads, and I usually do that with a piece of sandpaper, and you want to get them pretty well. I've already done this a little bit. This is like my third take on this, so I've already done them a bit. So you want to make sure you get all of those, get them well, make sure they're nice and shiny. Set that off to the side. You want to do the same for all of the leads of all the components. You want to go around them, get the oxide off the leads. If you ever work with lead, like you ever have a block of lead, scratch it and it'll look beautifully shiny. It's really shiny stuff. But within an hour or two, it's starting to gray up again. And that's because it really likes oxygen, and it will oxidize very quickly. And you don't want that oxide on there when you're soldering. Yes, the flux will take care of some of it, but again, that's not first choice. Okay, so those components, when you take things out of these tape strips, there's goop on the ends of the component. You want to make sure you get that off. I usually just pull it through some sandpaper like this a few times, rotate it, pull it through, do that like that, and set it aside. And you just go through all the components. I'm not going to make you watch me do that, but you do anything you're going to solder, all of the leads, everything that goes and gets in contact with the solder, you want to clean that before you put it in the board. So I will go off and do that. I will come back, and then we'll be ready for the next step. At this stage, it's a good idea to test as many components as you have the capability to test. So for example, this resistor, and yeah, it's within range. Just to make sure that you don't assemble a kit and then it doesn't work and you're trying to struggle to figure out which component's not working. With a small kit, I don't always do that. With a big kit, you definitely want to do that, because you do find components that are out of range, and then you would have to go through and debug when everything's soldered in place. That's a lot harder to do. So at this step, again, test the components you have the capability of testing. The tools you need today are a well-tinned fine tip soldering iron and the equipment to keep the tip clean. I like to have a pair of tweezers to bend leads nicely, a little bit of sandpaper to clean leads, a nice fine solder. This is 0.8, 0.5 is also good, various types of clamps to hold things in place, clippers that will clip down against the board tightly, and then a damp piece of tissue to help hold components in place with my fingers, and also to protect the components from overheating. Now I've got the board and components all cleaned and prepped, so it's time to start placing stuff on here and start soldering. What I'm going to do is I'm going to start in the middle with the lower stuff, resistors, and this plug right here for the IC. And then work my way out, because like taller things like the capacitors can get in the way as you're trying to hold stuff onto the board, because we're soldering on this side, but on this side we're going to have to be holding stuff in place, and it becomes difficult when there's stuff in the way like a big capacitor sticking up here. So that's the strategy. Let's start placing and soldering. Going with our strategy of the smallest, lowest pieces first, I'm going to place these 3 resistors. The first bit of artistry we're going to do is, when you have resistors like this, as you know, there's no polarization to resistors. They can go in either way. But I always like to align the tolerance bands to make sure they're on the same end. That adds a little bit to the eye. When you look at something, they're all lined up, they look better. Which end to choose? If there's a diode somewhere on the board, I will use the band on the diode to align the tolerance band on the resistors. Again, this is strictly for artistry. It's not technically necessary, but that's the way it works. So first I will go and place these resistors, and before I solder them, I'll come back and show you how I do that. What I've done here is I have used some square end tweezers to create a nice 90-degree in the lead, and spaced exactly as the holes are on the board. And when you do that, the component will just drop into the board very nicely. You won't have to shove it down. From that point, you hold it in place. You use your tweezers set firmly against the board, and you give the wire a little tweak. As you can see, this one's off to the right, this one's off to the left, and that will hold the component nicely on the board. While you're soldering, you can place your soldering iron on one side, your solder on the other, and it will make a very nice, quick connection. Just as a matter of course, I will use a piece of damp tissue and hold it on the bottom of the resistor to make sure it's seated flat against the board. Plus, it keeps the component from overheating. Now, obviously, you don't want to do that on water-sensitive components, but for most, a piece of damp tissue won't hurt them. There we have it. It's tight down on the board. There's no light underneath it. These ends look nice and symmetrical. They're not like one's not angled at different angles. They're both nice and square. The solder joints are acceptable. They both have a nice cone shape to them. They would be a little bit better if the cones had curved sides, so like this. If it's a ball of solder, that's not good. If it's a cone shape, it's acceptable. If it's a cone with curved sides, that's the best. Okay, so what we're going to do is we're going to clip the leads off, and that component will be done, and then we'll move to the next one. I like to clip it right down against the board. These are some old toenail clippers. They are almost as old as I am, but they do a pretty nice job of getting it all the way down. Another thing to be careful of is make sure you have the same amount of lead on both ends. See that? They're equal on both ends. And here's what I mean about dropping into place. You take it, and if they're done correctly, you just let go of it, and it falls into place like that. Okay, so make sure the component is centered, that there's the same amount of lead on both sides. And if the bends are correct, the resistor or the component will just fall into place. I've got my component in place. I check to see that my color bands are aligned for the artistic purposes. These leads are a little bit thinner than the other resistor, so it doesn't hold it as nicely against the board. And so what I'm going to do is I'm going to use my damp tissue trick to make sure it stays firm against the board as I solder. I've got the 3 resistors in place with the bands aligned as we discussed earlier. I think I'll go after this IC socket next. You notice there's an indentation on this end of the drawing, and there's also an indentation on this end of the component, and those two things need to line up. Sometimes I will bend over opposite corners on these leads to hold it in place, and then I'll use my damp tissue, damp not wet, to kind of keep that from melting and hold it in position while I solder. The IC socket is in place. The index marks align on both the socket and the board. All of the solder pads have solder all the way around the lead, and yeah, so that's in place, and an okay job. I think the next component I'll do is this audio out plug. It only goes in there one way, and it's pretty obvious, so I'll go put that in there and be right back. The audio plug is in. I think I call this audio out. I think this is audio in actually, and it's in. Again, each pad is filled and it's nice and flush and level with the board all the way around. The next component I'm going to do is the LED. Now you want to make sure you got the plus and minus right. You want to check it. And a reason to check over your components before you insert them is this LED in this kit was broken, so I'm going to have to substitute another one from another kit, and I'll go dig through my supply and use one of mine. Next I'll do these little capacitors. If the wire spacing isn't correct, don't ram them down in there. Use your tweezers or what have you to make some nice bends so they're symmetrical. Also, if the capacitor has a polarization, watch that. Of course these don't, so I will face the writing the same direction on both of them. But yeah, so those are the little artistic touches for these type of capacitors. This is the second capacitor. You can see these little subtle bends I have in here to make it fit nicely. And of course when I insert it in here, the first one's already in, but when I insert it in here, I want it the same height above the board, and again with the writing facing the same way. So I will go do that. The second one's in place, and for height, they are pretty darn close. And again, the writing is oriented the right way, and that's it. Okay, next component. Most of our remaining components are taller, so I'll kind of arbitrarily pick this power plug and do that next. There's a lot of slop in this component, so one trick is to just tack one lead down a little bit, and that way you can kind of maneuver this thing around, get it in there square and finish it out. Because if I solder all 3 leads down and then try to square it in there, it's not going to happen. Okay, it's done and in there squarely. I'll do these capacitors next. The only trick here is you want them down and flush. Usually I'll set it down, solder one lead, set it down flush, solder the other lead, and then if it's not laying flat on the board, I'll hold it in place and then touch one lead, make sure that side's down, touch the other lead again, make sure that side's down, and then it should be perfectly flat. So it's in place. Again, I check the polarization. I put this in here. I solder one in place. I make sure this is as flat as I can get it. Solder the other in place. When I looked, it was not flush on the board, so I just hold it down like this and quickly touch the soldering gun just long enough to melt the solder. It'll go flat. Back here again, this side will go flat, and then just a little bit back and forth. Don't hold it on there too long because you'll lift the solder pads, but that'll make sure that that is on there about as flat as you can get it. I'll do this little one next. Negative, negative, positive, positive. And if the leads do not go nicely into the holes, then again, use your tweezers, make nice bends, symmetrical bends to make a beautiful mount. Variable resistor is last, nothing special about it, just make sure the holes line up nicely, that it goes in there, and do a good job soldering it. That's it. And the variable resistor is in there, it's flush, it's nice and square. Almost forgot the last component, which is the IC. Critical thing is to make sure that the notches align, the notch here and the notch in the socket. And usually these legs are a little too wide, like this one was. So I squeeze them in a little bit, make sure they're square, and ensure that I've got the thing still oriented correctly. Set the thing in there and then give it a gentle pressure around, make sure it's seated, and that should do it. I've got it plugged into my 12-volt battery pack. Here's the microphone coming in and the speaker output, and as you can hear from the speaker, hello, 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 testing 1, 2, ouch, 3, it is working. Okay, there we have it. Okay, it's assembled. Let's take a quick look around. On the top, the components are all nicely aligned with the silk screening on the board. Things are square, they're flat, there's no light underneath components where it shouldn't be. The resistors are aligned, the color bands are aligned just for looks, and the writing on these capacitors are lined up, and yeah, so overall it looks okay on the top. Let's look on the bottom. This is where there's some room for improvement. These smaller leads should really all be cut off at the same height. The bigger leads you can get some leeway on because they're just tough to cut off. You can put this on a sander and sand it off. I don't like to do that because it creates lead powder and you get little bits of everything everywhere and it can short stuff out. What would you call it? Consistency of the solder connections is not great. That's where I grade myself down. But yeah, overall, I mean, technically it's competent, but you know, the artistry, especially on the bottom, is a little bit weak. I would give myself overall kind of just a B rating on it. Okay, well that was it for this little amplifier project. I hope you found it useful and interesting in your home DIY electronics.